equation of a circle. It's like the generic form, all right? And when an equation is in the standard equation, you can pick out the center and the radius, the coordinates for the center and the length of the radius, okay? The coordinates of the center are represented by h and k. So it's x minus the x coordinate for the center and y minus the y coordinate for the center equals the radius squared, okay? And so if you have the center and the radius, you can graph the equation. And if you have the center and the radius, you can go backwards and you can write the equation, okay? But in order for you to pick out the center and the radius, it has to be in this form. If it's not in this form, you can't tell what the center and the radius is. You need to recognize that because it's x minus, because the standard form is x minus the x coordinate, that when you're looking at an equation that's already in standard form, realize that, for example, if the center was -2, -3, okay? If I were to go put this in standard form, this is h and this is k. So it's x minus -2, which will change to what? Plus 2, right? So when you're looking at the equations already in that form, when you're picking out the center and the radius, you're going to do the opposite sign because of this subtraction sign that's in the standard form, okay? If this was x plus 2, like over here, this would be plus y plus 3 quantity squared equals whatever the radius is squared. If I'm looking at it already here, the only way that this could end up being plus 2 was if that x coordinate was negative, because it would be x minus -2. Does everyone understand that? So that's why when you're looking at it already in that form, you do the opposite sign for those coordinates, because that's the only way it ended up that way. Okay? And so our first example says, write the standard equation of the circle with a center of -4, 0 and a radius of 7.1. So the first thing you need to do is write what the standard equation is. Okay? So it's x minus h squared plus y minus k squared equals r squared. Identify what the center and the radius is. So this is h, this is k, and this is r. And then just plug it in. Okay? So it's what? X plus 4 squared plus y minus 0 squared equals 7.1 squared. Okay? Now, you're going to use your calculator, and you can actually square that. But what you need to recognize is that when you have y minus 0, if the y coordinate is 0, you're not going to see y minus 0 parentheses squared. Because when you subtract 0 from it, it doesn't change it, right? So that 0 is not necessary. So what you will see is x plus 4 squared plus y squared equals, and then 7.1 squared is 50.41. This is what it'll look like. So when you see if it's in that standard form and x squared or y squared is by itself, that's because that coordinate for that center is 0. All right? So this is the standard form. So the first set of problems, they'll give you the center, they'll give you the radius, they'll tell you to write the form of the equation, the standard form of the equation. Okay? Then you'll have them where they'll give you the standard form of the equation. You have to pick out the center and the radius. Okay? So you have to work backwards. Now, does anybody know, if I'm looking at this equation right here, how do I know that's a circle? Does anybody know? If both x and y are squared, then we know the graph of that is a circle. If both x and y are squared, we know the graph of that is a circle. If x and y are both to the first power, we know that's linear. We know that's a line. If only one of them is squared, then that's a quadratic. That's a parabola. Okay? And so you'll start to recognize, based on based on the exponents, you'll start to recognize what these graphs look like. Okay, you may not know specifically what it looks like, but you know its general shape. So if x and y are both squared, it's a circle. Okay, now, do you think your calculator will graph a circle? No, why?
Not, because you can't.
Because there's a reason why. And that is a reason. When you go to put it in, it's y equals, not y squared equals. But your calculator only graphs functions. Is a circle a function? No. It fails what? The vertical line test. It fails the vertical line test, so it's not a function. So your calculator can't graph a function. In order for you to put something in your calculator, it needs to be y equals. Okay? Now, we can graph this very simply by hand. Okay? If we know the center and we know the radius, and we'll do that in a minute, you plot the point in the center, and the radius tells you how far to go out in each direction. And you could do a rough sketch of that circle, okay, which is what we'll do in a minute. Know that this doesn't have anything to do with this lesson. This is just a side note. If you wanted to graph that circle on your calculator, you can trick your calculator into doing it by solving for y. When you solve for y, for example, we have y squared equals, how do we get just y equals? Square root both sides, right? When you take the square root of both sides, you'll end up with plus or minus, right? So y will equal positive square root of something, and then y will equal negative square root of something. If you put both of those in as y1 and y2, each one of those represents half of that circle. So your calculator can graph half the circle and then the other half of the circle. So when you graph them together on your calculator, it looks like a circle. They're just not quite connected. So you can make your calculator do it. You just have to solve for y in order to be able to put it in y1 and y2. When you solve for y, you'll end up with positive and negative, which is your y1 and y2. Okay? But that is not how you want to graph these. We want to graph these based on their center and their radius, and just graph it. Okay? But I just wanted to point that out. Okay, so looking at these two examples, let's just check your understanding and make sure that given these problems, we can pick out the center and the radius. They're already in the correct form. Okay, for the first one, what's the center? Negative 12, negative 15, and what's the radius? 3. Because when you see that equation written, that radius is already squared. So in order for you to know what the radius is, you have to take the square root. So the square root of 9 is 3. Okay? And so for the next one, and just leave it in fraction form. The center is what? Negative 15 over 2. And what's the y coordinate? Negative 5. And the radius is 4. Now, when we take the square root of something, we normally do plus or minus. Why don't we do minus? Because it's a distance. You can't have a negative radius. All right? So you only consider the positive case. Okay? Any questions? For the next set of problems, again, you're going to have to write the standard equation of the circle. Okay? You need the center and the radius to write that equation. They give you the center, but they don't give you the radius. So let's see if we can figure out how to find that. Oh, never mind. Write the equations of those circles. Then we'll do that one next. Okay, so this is h and this is k, right? And this is my radius. So it's x, what? Plus 13 squared plus y plus 1 squared equals 9, because it's the radius squared. So when you have to write the equation, you have to square it. If you have the equation and you need to pick out the radius, you take the square root of it. All right? Good. Now, for the next one, this is h and this is k. So you should have x minus 1 squared plus y plus 13 squared equals 22. Yes.
Alright, so if it like already gives you the equation, you see the radius, how do you know like the radius was like already was in the square root?
Because this form, the radius is already squared.
Oh, okay.
It's equals r squared. So this is already squared. So to pick out the radius, you have to take the square root. So if they give you the radius, you have to square it.
But I'm saying if they're like let's say this like it's like equal to 9, right?
Right here? Yes.
Yeah. How do you know that it wasn't like the square root of 9 already?
It would say if if the radius is 9, then it would be equals 9 squared. And you will never see it written like that.
Yeah.
It will be 81.
I was just making that. Yeah. Okay. I see.
You can't have, if there's a number right here, it's already squared. Okay? So, if we square the square root, it ends up being itself. Okay? If we square square root, it ends up being itself. So that's how come it equals 22. So when you see it written in this form, what it equals to is the radius squared. It's already squared. So if you have to tell me what the radius is, you need to take the square root of it. Okay? Any questions? Okay. Now, this is the one I was talking about a while ago. So we have to write the standard equation of the circle. Okay? They tell us a point on the circle, and they tell us the coordinates of the center. And so to write the standard equation, you need the center and the radius. How can we find the radius? Distance formula. Very good. The distance formula. Think about it. They're telling you, here's a circle. The center is 5, -1, and a point on the circle is 1, 2. So the radius is the distance from here to here. So you have to use the distance formula to find that radius. Okay? And just in case anyone doesn't remember what the distance formula is, it's the square root of what? Y2, or either x's or y's, it doesn't matter. Y2 minus y1 plus x2 minus x1. You're adding them, so it doesn't matter whether you have x2 minus x1 squared plus y2 minus y1. Yes?
Can't you just add a root to the r squared problem and get r squared and then square root of
Yeah, that's smart. Well, but you have to know what the equation is. Oh, yeah. Oh, plug it into the, oh, yeah. That's, you can do that too. See, I love when y'all think of things that I haven't thought of.
Okay,
Yeah, I thought that was
you see the center.
It shows you some.
Okay, let me finish this, so I don't confuse anyone more. But, yes, we'll do that. That's smart. I love when y'all think of stuff I hadn't thought of. Okay, so we can use the distance formula to find the radius. So, radius equals square root of. So we'll say this is x1, y1, and we'll call this x2, y2. Okay? And so it's -1 minus 2 squared plus 5 minus 1 squared. So that's -3 squared plus 4 squared, which is 9 plus 16, which is 25, right? So it's the square root of 25. So the radius equals 5. So now you have the center and you have the radius, so you can go write the equation. So the center they gave us was 5, -1. So here's our information we need to write. So it's x minus 5 squared plus y plus 1 squared equals 25. Okay? So we had to find, You have to find the radius first and then use the center and the radius to write the equation. Okay? Any questions? Now we'll look at what she was talking about. She said, couldn't you just plug in x and y into your generic equation of a circle and solve for r? Yeah, you could. And you might find that easier, especially if you don't remember what the distance formula is. Okay? Very smart. So, let's move this down. Okay, so if you're going to do it this way, you can't use the center as your point to plug in. It has to be a point on the circle. Okay? Can't use the center. So this is our point 1, 2. So this is the point on the circle. So this is method number 2. Method number 2, to find the radius. So our point on the circle was 1, 2, right? Okay. And so take the generic standard form. So that's x minus h squared plus y minus k squared equals r squared. So this, we're going to plug these in for, and the center. Plug in the center and x and y. So this is our point, and the center was 5, -1. So h and k is the center. Okay. So this is x, this is y, this is h, this is k. Okay. So it's 1 minus 5 squared plus 2 plus 1 squared equals r squared. Everybody see? Okay. So then this, who's sitting now? Am I sitting now? Okay. This is our point on the circle, that's x, y, and this is our center, so that's h and k. So I'm substituting in x, y, h, and k right here. Okay? So this is -4 squared plus 3 squared equals r squared. So that's 16 plus 9 equals r squared. So 25 equals r squared, so r equals 5. That's a great method. Okay? So you can use whichever method you prefer. All right? If you prefer to plug in x, y, h, and k and find r, great. Probably lessen your chance of making a mistake if you mess up the distance formula. Okay? Any questions? Okay, so now I want you to try this one. Okay, so this is h, this is k, this is x and y. So x minus h squared plus y minus k squared equals r squared. So like I said, whether you do this method or the other one, you're still doing the same thing. You're still doing the distance formula, regardless. What? Yeah. Is it what? Yeah. And so it's 5 minus 11 squared plus -6 plus 9 squared equals r squared. So it's -6 squared plus 3 squared equals r squared. So it's 36 plus 9 equals r squared. So 45 equals r squared. So r equals the square root of 45. Leave it like that, because when you plug it into your general form, you'll have to square it, and it'll just be 45, equal to 45. So my center is 11, -9, and my radius is the square root of 45. Okay? So now we're going to write the equation. So remember, this is h and this is k. So it's x minus 11 squared plus y plus 9 squared equals 45. Because when you square 45, the square root of 45 just equals 45. Any questions? How we do? Okay, good. Now, in this one, this is simple. They give us the general form and we have to graph it. So if they tell us the center, by giving us the general form, they're telling us the center and the radius. So, what is the center of this circle? -2, +3, and the radius is 3. You have to take the square root, okay? Ignore this. Pretend like that circle, you didn't see that circle. The circle was not there. This was a blank graph. What circle? Good.
What circle?
There was no circle there. You never saw a circle there.
Why are you still talking about a circle?
Okay. So, here's our blank graph, and we have to graph this circle. We look at an equation, we know it's a circle. How? X and Y are both squared. X and Y are both squared. Even if it didn't say equation of a circle, we would still know it was a circle because X and Y are both squared. So the center is -2, 3. So we go find -2, 3. And we plot that point. That's the center. And the radius is 3. That means from the center, it goes out 3 units in all directions. Now, I can't do diagonal directions, but I can do straight up and down and straight left and right. From the center, I count out left, right, up, down 3 units. And I mark it. Okay, so from the center, we have to go up, down, left, and right 3. So count. 1, 2, 3. Put a little dot. Then to the left. 1, 2, 3. And down. 1, 2, 3. And to the right. 1, 2, 3. Okay? So my circle needs to go through all those points. That is what I know. So you just draw a rough sketch of what the circle looks like. I will use my fancy smartboard to draw that circle. Okay? So yours is going to be a rough sketch. It doesn't have to be pretty. It's just a rough sketch. But you need to label the radius and the center. So the radius is 3 and the center is -2, 3. Okay? Okay, number 5 says, use the information provided to write the equation of each circle. Again, it's the same thing. What do we need to write the equation of the circle? The center and the radius. Looking at this graph of the circle already there, you can figure out what the center is. Very good. So, this is the center. So that's +2, -2. Now, when you go to pick out your radius, be careful to what each hash mark represents. Don't let that trick you, okay? So the center is 2, -2. So my radius, each hash mark represents a half a unit. So that's 1/2, 1, 1.5, 2. So my radius is 2. So tell me what that equation looks like.
X minus 2 squared plus 2 squared
Equals 4. Very good. Okay, so here we have an equation. How do we know it's a circle?
because it says it is.
I don't care that it says it is. I see that x is squared and y is squared, so I know that's a circle. I know I can get it from this form into this form. Okay, so in order for me to get it into that form, I need to be able to get x squared into x minus some number squared. And I need to be able to get y squared into y minus some number squared. R squared is just a whole number. It's just a constant, right? So I know the first thing I need to do is take that constant and move it to the other side. Because whatever's on the right side of that equal sign is going to be what my radius squared is. Okay? So, I know without a doubt, this is going to equal negative 139. Okay? Put things in the right place. Once I move that 139 over, this is what I have left. I need to go from this to this. Now, I need you to dig deep. I want you to think back to first quarter. Think back to first quarter. Let's pretend like the y's aren't there. Let's just look at the x's. I have x squared minus 28. How can I make that turn into x minus some number, parentheses squared?
You group it or something like that. You
Yeah.
simplify.
You can't group. There was something we did, and the reason why I taught you this in first quarter was because we needed to use it here. No, we can't factor by grouping.
Did you use ABC method?
Oh, my first.
That's not-
That is exactly what it is. Completing the square. Completing the square, remember, you have A and B, and you have to find C. That makes it a perfect square trinomial, remember? You take whatever B is, divide it by 2, square it, add it to both sides. Refreshing your memory? Okay. For example, let's look on the board over here. So, I'm going to put x squared plus 8x. Okay? If I need to take this, which is essentially what I have right here, right? X squared minus 28. I have to add something to both sides that's going to make this a perfect square trinomial. So what's b?
8,
8. Half of 8 is
4,
4 squared is
16.
16. So we add 16 to this side and 16 to the other side. Okay, because there's some number right here. Okay? And then we write this as a binomial squared. So what is this written as a binomial squared? X plus 4. Remember? It's you use that same sign. It's x either plus or minus whatever b was divided by 2. So we take this and turn it into this. Now, x plus 4, parentheses squared, is in our right form. So how many times are we going to have to do that?
Twice.
Twice. We're going to do it with x, and we're going to do it with y. And we're going to do it all in the same step so that it makes it simple.
Let us go.
No.
Okay, I'm going to give you one to do, but let's do this one together. So, first thing you need to do, you need to get your constant to the other side, because that's your radius squared. Okay? Now, you have to rearrange it to where you have your x's together and then your y's together. And you want to leave a blank after your x's and you want to leave a blank after your y's because you're going to be adding something to both of those. And then you want to make sure that you add those two things to the other side too. So, we have x squared minus 20x plus blank.
Equal blank.
Not equals, not yet. So, I just put these together, okay? Plus, this is my plus that goes right there. Plus, y squared plus 16y plus blank. Now, if I added blank and blank to the left, I have to do what? Add blank and blank to the right, correct? So, plus blank plus blank. I ran out of room, but that's
We
okay.
need 2 blanks?
Yeah, because if I add something here, I'm going to have to add it there. And then when I add something here, I have to add it there. Got to keep it equal. Equal and balanced. Yeah. Okay, so let's complete the square for both of those. Half of 20 is 10 squared is, so we add 100 to the left, we must add 100 to the right. Now let's do the same thing for y. Half of 16 is 8 squared is, so if we add 64 to the left, we must add 64 to the right. Okay, so now we have to take these and write these as binomials squared, and then that's it. Okay, so what is this? So it would be something squared. So that's x minus 10. Here's our plus. Something squared, what is that? 5 plus 8 equals, calculate that, 25. That's it. What's my center? 10, negative 8. And what's my radius? 5. So if it asks you to write the equation, you stop there. If it asks you for the center and the radius, then you just take out the center and the radius. You couldn't know the center and the radius unless you put this in this form. So you already know how to complete the square. We just haven't done it since first quarter, but we're refreshed now. So that's why the method of completing the square is important. We're rearranging these equations to get them in the correct form. We're going to do the same thing again when we cover parabolas. Okay, but for then you'll only have to complete the square once. Circles, you have to complete the square twice. But do it all in the same step. Okay? Simplify the process. All right? Any questions? All right, I have one for you to try. Okay, so write the general equation and tell me the center and the radius. Okay, so 10y, negative 10y has to be moved over there. So we'll have x squared minus 18x plus blank plus y squared plus 10y. When you bring it over, it becomes plus 10y plus blank equals negative 90. We added blank and blank to the left, so we have to add blank and blank to the right. Plus blank plus blank. Okay, half of 18 is? 9 squared is?
81.
Add 81 to both sides. Half of 10 is? 5 squared is? Add 25 to both sides. Now, this can be written as x, what? X, thank you, minus 9 squared plus y plus 5 squared equals 16. So the center is, what's the center? 9, negative 5. And the radius is 4. Very good.